Welcome to gcsemathshelp.co.uk. Please go to the site or use the links below in the description to go to the worksheets which go with this video, and also in the description are little time clips to be able to go to the part of the video at the topic you're struggling the most. At our site or on our channel you'll find videos which go with all the topics at GCSE Maths with all the exam boards. Okay, I hope this has helped you.
Hello and welcome to this first video on number. I'm Dr. Debbie Barrett and we're going to be looking at some basic structure and calculations. Firstly, we're going to look at ordering numbers. To do this, we need to think about where they are on a number line, and so to do that we're going to think about inequalities. On a number line we always have numbers on the left being smaller than numbers on the right. This is quite crucial in that you don't get confused that sometimes a number line will have an arrow on the end showing numbers increasing to the right. So just be careful that you forget about that and don't think of it as an inequality sign. Here, for example, minus 3 is smaller than 5 because it's on the left of 5 on the number line. We might have to work with fractions or decimals, so for example 7/10 or 0.7 is smaller than 0.9. And you might have inequalities that are the other way around. If you don't like the fact that 3.2 is bigger than 2.7, you can always switch it the other way around so that the number on the left is smaller than the number on the right, and then your inequality sign always goes in the same direction. You might be asked to find numbers x such that they are smaller than minus 2. So for example, here's minus 2 on the number line. We could have minus 3, minus 4, minus 5. I've just picked integer numbers at the moment. That means whole numbers, whether they're positive or negative. You could be asked for numbers x greater than or equal to 3. If you prefer to view this as 3 less than or equal to x, that's perfectly the same. So numbers that are bigger than or equal to 3, 3 is included, so is 4, so is 5. Again, I've just picked integer numbers or whole numbers that are either positive or negative. And in this case we've got an inequality where minus 1 less than or equal to x less than 2. And if I'm asking you for the integers that satisfy this inequality, here, because it could be equal to minus 1, that's the first one in our list. Then we have 0, and then we have 1. Note that 2 is not included because we didn't have an equality here. What I've done here is then shown you this set of numbers represented on the number line. When we have minus 2 less than, a strictly less than here has an open circle, and all the numbers that are smaller than it, i.e. all the numbers off to the left, are included. For this one, where x is greater than or equal to 3, the equality means that we have a filled in or coloured in circle here, and then this arrow represents numbers that are bigger than 3. And finally for this one we have to have the closed circle at minus 1 because of the possible equality, and here the open circle at 2 because it's definitely not equal to 2, and everything in between is okay. Another important topic in number is that of BIDMAS, and it underpins so much of what you do that you really have to get to grips with it. BIDMAS stands for brackets, indices, division, multiplication, addition, subtraction, the first letter of each word making up BIDMAS. I've grouped together division and multiplication because essentially, although the word division comes before multiplication, actually you do division and multiplication in the order that you see them. Same with addition and subtraction. Addition doesn't get done in preference over subtraction, it just gets done in the order that you see it. So brackets come first, then indices, then anything that's been times or divided, then anything that's been added or subtracted. So for example in this case we need to deal with the times before the subtract, so we get 30, and then we do the subtraction, which is minus 26. In this case the brackets come before the multiplication, so we have to work this out to be minus 1, and then we realise the answer is minus 6. Here we have an index number, so a number that's been raised to a power. And here you need to be really careful because you need to realise that this is minus 4 times minus 4. So that is actually plus 16 because the minus minus makes a plus. And so the answer is 69. Now in here we essentially have a bracket that needs to be done before the index. And when we look at the bracket, we have a times that needs to be done before the plus. So we have 5 plus 6, which is 11, all squared, which is 121. Here are some trickier examples. If we have a big divide sign like this, what was essentially missing is that this is like having brackets around the 7 plus 3. It means that all of that has to be done first before dividing by 2. So here the big divide sign is actually overruling the fact that we have a divide in here. If I move the position of the divide sign, then here I'm adding and here I'm dividing. So I do this division first, which is 1.5, and then I add it to 7. So notice how you get a different answer. A square root is another symbol which does a similar thing. You have to take the square root of everything inside the square root. So here you have to do that first, and in order to do it we have to do the index before we then add. So we get the 16, add it to the 9, and then take the square root. At this stage, have a look at section A on the worksheet. Let's look at factors, multiples and primes. A factor is essentially a divisor of a number, so something that goes exactly into it. So if we're looking at factors of say 24, 1 goes in 24 times, 2 goes in 12 times, 3 goes in 8 times, and 4 goes in 6 times. 5 doesn't go in. And that's it, we've reached the end of our list because we'd come all the way down this list and we were starting to go back up the other side here. So the best way of catching all the factors of a number is to list them in pairs. Next, let's look at multiples of a number. Multiples just means essentially times tables of that number. So we need to start with 1 times the number. 1 times 8, 2 times 8, 3 times 8, 4 times 8, 5 times 8. Obviously this list carries on going forever and ever, so you'll be asked for the first 5 or the first 4 multiples of a number. Just remember to always start with 1 times the number. Finally, prime numbers, these are numbers which have exactly 2 divisors, 1 and itself. So here's your list of prime numbers. Things like 8, for example, are not prime numbers because 1, 2, 4 and 8 go in, so it doesn't have 2 divisors, it has 4 divisors. Note that 1 itself is not a prime number because 1 is itself, so it doesn't have 2 divisors, it only has 1. Now let's look at HCF and LCM. The hardest thing about these things is you'll be asked to find the HCF of something and you might not remember what it stands for. It stands for highest common factor. So here, list all the factors of both numbers to begin with. So if it asks for the highest common factors of 8 and 12, list all the factors of 8, then list all the factors of 12. So remember to list them in pairs to make sure you catch them all. Next, compare both lists and just choose the biggest number. It really is that simple. For LCM, this stands for the lowest common multiple. So we're going to use a similar approach, simply list multiples of both numbers. Now obviously these lists go on forever and ever, so list a few of the first number and then list a few of the second number, and hopefully at that stage you can compare the lists and pick the smallest number. If however you haven't yet got a number in common to both lists, then all you do is carry on with the first list and carry on with the second list until you find a number that's in both lists. And remember, you're looking for the smallest number. In order to do the prime factorisation of a number, what we really need to do is a factor tree. So here's the number 56. We need to think of 2 numbers that multiply together to make 56. Now any 2 numbers will do, but I'm choosing 2 and 28. So 2 times 28 makes 56. At this stage you look at those 2 numbers and you decide, now is any of them a prime number? If it's prime, you stop there, you put a ring around it and you've finished with that branch. But 28 is not a prime number, so we carry on and we think of 2 numbers now that multiply together to make 28. For example, 4 and 7 will do. Here we again look at the numbers, decide if they're prime numbers. 4 isn't a prime number, but 7 is. So now we have to think of 2 numbers that multiply together to make 4. That's 2 and 2. They're both prime. By the time we've got to this stage where all of the numbers at the end of the branches are all circled, we can stop. And then we can pull them all together and say 56 is equal to 2 times 2 times 2 times 7. So this is how writing it as a product of prime factors. At this stage you can pause the video and go and work on section B of the worksheet. Now let's take a look at powers and roots. So 1 squared literally means 1 times by itself. So we get 1 times 1 is 1. 2 squared means 2 times by itself, so we get 2 times 2 is 4. 5 squared means 5 times by itself, so we get 25. 8 squared means 8 times 8, so we get 64. If we now look at what square roots are, square root of this number here would give you the number here that you originally started with. So when you say what's the square root of 1, you're thinking what number times by itself to give you 1, and the answer is 1. What number times by itself to give you 4, and you get 2. What number times by itself to give you 25, the answer is 5. And what number times by itself to give you 64, the answer is 8. Let's look at higher powers though, like cubes. 2 cubed means 2 times by itself 3 times, that's what the 3 indicates. How many times 2 has been multiplied by itself? 2 times 2 times 2 is 8. So the cube root of 8 means what number times by itself 3 times to make 8, and the answer is 2. 5 cubed means 5 times 5 times 5, so we get 125. So the cube root of 125 means what number times by itself 3 times to give you 125, and that's 5. 3 to the power of 4, 3 times 3 times 3 times 3 is 81. So the fourth root of 81 is 3. What number times by itself 4 times to give you 81, and that's 3. Let's now look at integer and fractional indices. So let's look at the negative powers first. If we have 4 to the minus 2, you can think of the minus as just saying 1 over, so it's giving you a reciprocal of the rest of it. So that's 1 over 4 squared, so that's 1/16. 5 to the minus 1 could be written as 1 over 5 to the power of 1, but we don't need the 1 in there because 5 to the 1 is just 5. And 1 over 81 could be written as 1 over 9 squared, so that's 9 to the minus 2. Or you might realise that it's 3 to the power of 4 gives you 81, so we have 3 to the minus 4, the minus just meaning 1 over. The rule we've been using is this rule for index laws with reciprocals, so a to the minus n is 1 over a to the n. And this is where this topic is crossing over slightly into algebra, and there'll be more of this in the algebra topics. Looking now at fractional powers, now this is very much aimed at the higher end of the paper, the A star end. A fractional power of a half literally means the square root of something. So 25 to the half is the square root of 25, which is the number 5. And in fact, if we have 1 over n as the power, it's the nth root. So for example, 27 to the 1/3 is the 3rd root, which means it's the cube root. We might have compound calculations to do. So for example, 81 to the 3/4, we need to split this into 1/4, which is the 4th root of 81, and then cubing that, which is 3 cubed is 27. So it's more sensible to split this up into 1/4 first and then do the power of 3, because we're making this number much smaller, making it 3. Whereas if obviously we did it the other way around and we did 81 cubed, we get a really massive number, and I don't think anyone's going to know what the 4th root of that really huge number is. So this is definitely the better way of doing it, doing the root first and then doing the power second. Next up is thirds and multiples of pi. So this is again aimed at the higher level of the paper, the higher end of the paper. Firstly, we need a few rules about thirds. So thirds are just numbers that are square roots, and as long as your number a and b, as long as these are not square numbers, so something like 2 or 3 or 5, then actually we can't go any simpler than that, and so we keep them as an exact number. So these are the rules that we need to use. Here are a few examples of how to use them. Root 2 times root 3, we just use this rule here to say that's root 2 times 3, which is root 6. If we have numbers in front of the square roots, like in this rule, all you do is you multiply the numbers together first, and then the numbers under the square roots together separately. So we have 2 times 3 is 6, and the 3 times 5 is 15. Here's a division, so root 20 divided by root 5, we're going to use this rule here to say that that's root 20 over 5, or root 4. But of course in this case it does actually simplify further because this is a square number and we get the answer 2. Here's another one. We're going to do 4 divided by 2 first of all to give us 2, and then we're going to do root 12 over root 6, so that's root 12 over 6, 12 over 6 is 2. You might be asked to do some simplifying with surds. So in this case, if you're asked to simplify root 32, we need to try and find a square number as a factor, because if you have a square number we can use this rule backwards to say that we can split this up now into the square root of 16, square root of 2, square root of 16 is 4. So look for a square number if you can. Another way of dealing with simplifying surds is to treat them like a letter. You've got 3 of something and 2 of something, so that's 5 of something. So this is a bit like an algebra question then. When we've got brackets, double brackets, we need to expand the brackets first, and again this is an algebra topic so that there will be more on this later. You do first, outside, inside, last, giving us this line here. And then here in this question we've got a bracket all squared, so remember to write both brackets times together because squaring means that thing times by itself. Then use your FOIL, first, outside, inside, last, to get this line here. And notice that 2 root 3 times 2 root 3, we have 2 times 2 is 4, and root 3 times root 3 is 3, not 9. Some people make a mistake here. And then here we notice that we can actually simplify further because we have 2 terms involving root 3, so these are like terms. So we've got minus 14 of them minus another 14, so that's minus 28. And obviously your numbers just simplify easily as well. Pi is much easier to deal with actually. Again, think of it like just like a letter in algebra, so 2 pi plus 5 pi is 7 pi. If we have 4 times 3 pi, we just times the numbers together to give us the 12. If we've got 3 pi all squared, then that's 3 pi times by itself, so that's 3 times 3 for 9, and pi times pi, pi squared. And here's a division, we've got 12 pi over 2 pi, the pi's are going to cancel because you've got times pi divided by pi, so they cancel, and 12 over 2 is the same as 6. So here the key is really to think of your algebra rules. Now we need to rationalise the denominators of surds. Again, this is aimed very much at the A-star end of the paper. In this case, we have a surd in the denominator, and this is an irrational number. In order to make it rational, we just need to times it by itself. So root 3 times root 3 will give us 3. This is now a rational number in the denominator. But because we've times by root 3 on the bottom, we need to times by the root 3 on the top as well, because this means overall we're timesing by 1, and so we have an equivalent fraction. There'll be more on fractions in future videos. Now we have 2 times root 3 is 2 root 3, root 3 times root 3 is just 3, and this is rationalised. In this example we do the same thing, we times by root 6 in the bottom, but we also do it in the top. The bottom becomes 6, the top combines to become root 12. And then root 12 simplifies to root 3 times root 4, and root 4 is just 2. Now we can see we've got lots of simplifying. The 3's cancel and the 2's cancel, giving us root 3 over 1, or just root 3. This section is covered in section D of the worksheet. Finally, we're going to be working on standard form. Now a number can be written in standard form if it can be written as a times 10 to the power of n, where a is between 1 and 10. Crucially, a could be equal to 1 but not equal to 10. Let's deal with large numbers first. If we've got a number like 320, what we do is we move the decimal place to be just after the 3, so it fulfills the criteria of being between 1 and 10. Then we think, what do we need to multiply this number by to give it back the 320? And since we have 100, timesing by 100 as being the same as timesing by 10 squared, we've now got it in the right form for standard form. Let's look at this one. We've moved the decimal place to being straight after the 1, so it fulfills the criteria for A. And now we just need to see, well, how many tens do we need to move it by? 1, 2, 3, 4 in order to get to the original number. Here we've got 1,000,000. We need to move the decimal place 1, 2, 3, 4, 5, 6 times. And here we're going to move the decimal place 9 times. For small numbers, we need to understand what it means to be a negative power, like we were talking about earlier. So if we have times 10 to the minus 1, that's the same as times 1 over 10 to the power of 1, because it's a reciprocal when you have a negative power. And timesing by a tenth is the same as dividing by 10. We can extend this to any power though. 10 to the minus n is times 1 over 10 to the n, or divided by 10 to the n. So here we're moving it 1, 2, 3 places, which means we want to divide 6.9 by 1,000, or 10 cubed. Because we want to divide by 1,000 or 10 cubed, that's the same as timesing by 10 to the minus 3. And here you can see the decimal place being moved 7 times, so that we can write 0.000001 in a much more easy to read format. That's the end of this video. Thank you for listening, and I hope you'll tune in for another video soon. Don't forget to finish the worksheet by looking at section E.
I hope this video was of use to you. Remember, you go to our site below at gcsemathshelp.co.uk. You'll find video clips and worksheets for all of your GCSE maths to help you with. All of this is free for you, but if you could just please let the advert, which is about to follow, run, okay, that'd be much appreciated. Thank you.